Hello friends, I am George McQuan and welcome to JJ's Classroom. If you like my videos, then don't forget to hit the like button as well as to subscribe the channel. Today in lecture number 4, I am going to discuss with you the factors affecting on solvent extraction. So let's start. In lecture number 4, the topic of our discussion, that is, discuss briefly the various factors that are responsible for affecting the process of extraction. In that, the first point, that is called salting out agents. Those are the higher concentration of inorganic salts. Point number 1, that is, the salting out agent has more attraction towards the common ion with distributing species, which will decrease the solubility of the species in aqueous phase. Okay, so this point means when you add the salting out agent that has a higher attraction towards the species which are dissolved in the aqueous phase. The salting out agent are added in aqueous phase. You know that in solvent extraction we have two phases. One is the aqueous phase, water, and second one is the organic solvent. Okay, and both are immiscible with each other. So when you add the salting out agent, there was a question where to add it. Okay, the salting out agent has a higher tendency towards the water molecules. The salting out agent has a more attraction for water molecules, and because of that reason salting out agent are always added in the aqueous phase. Okay, the ability of these ions to bind the water molecule is very high. Okay, which ions? The ion of the salting out agent, like high concentration of inorganic salt. Okay, they have a higher tendency to bind with the water molecules, and because of that reason it is added in aqueous phase. As a result, what happens? The organometallic compounds are enhanced to move towards the non-aqueous layer in contact with the aqueous layer. That means it is salting out agent are generally used whenever there was a separation of organometallic compound is there. Next slide, that is about how the mechanism of the salting out process. So friends, here, okay, these blue dots indicate, blue circle indicate the solute particles that are present in an aqueous phase. Water molecules are in gray color, and those are the charges of salting out agent. Okay, when you add more salt in that aqueous phase, what happens? According to the statement that salting out agent has a more attraction toward the water molecule. When you add more salt, they attract more water molecules. Okay, here you can say the solid particles are surrounded by the water molecules, so it is difficult to extract those particles, solid molecules. But after addition of the salting out agent, what happened? In this figure, those salting out agent attract the water molecule towards them, and because of that reason the solute particles which are surrounded by the water are now free. Look at the figure. Now these solute particles are free, no water molecules are surrounded by or surrounded the solute particles. Now when you add organic solvent in this aqueous phase, what happens? It is easily extract those solute particles from the water. Why? Because now water molecules are binded to the salting out agent. Now they do not interfere, that means they do not bind the solute particles with them, and they are free to extract by the organic solvent. So by this way, by this mechanism, we can understand by addition of the salting out agent in the aqueous phase how they attract the water molecules or bind the water molecules to them, and hence free the solute particles for the extraction by the organic solvent. That is the mechanism. The reverse of that is called salting in process. It is also very easy. When the concentration of the salt is very low, solubility is increased. That means it is the reverse of the salting out. the charged particles or the salting out ions are less. Because of that reason, the water molecules are free from that salting agents, and hence they further bind to the solute particles. That means they then surrounded the solute particles, and because of that reason the process of extraction becomes complicated or difficult. That is called salting in process. Salt molecules stabilize the protein molecules. Okay, that is the process, decreasing the electrostatic energy between the protein molecules, which increase the solubility of protein in water. That is the process of salting in. Next point, that is called masking agent or synergistic agent. Okay, why masking agent are required? The first line tells us about that the presence of one metal may interfere in the extraction of another metal. That means during the practical, if in your aqueous solution, if more than one metal are present, then when you add organic solvent, which metal undergo extraction, that is a question mark for us. So one metal interfere in the extraction of another metal. Okay, so because of that we must prevent the extraction of another one in the presence of next one or the first one. The process is done with the help of some agent known as the masking agent. In this condition, the reagent known as masking agent are added to water. That is also important as the MCQ purpose. Okay, the masking agent are added in blank phase. The answer will be water or aqueous phase. Now, this reagent, that means the masking agent, has a tendency to combine with the interfering metals. Okay, it forms such a compound with it which does not interfere in the extraction process. Some like complexometry, there was a formation of complex between the interfering ions and the masking agent. This compound itself does not experience the extraction also. Okay, question is arise in your mind, that means when you add the masking agent and if it combine with the interfering ions, then it is also extracted? No, the complex or the compound which formed by the masking agent with the interfering ion also does not experience any extraction. Well-known example is given to you. If in the solution you have two metals, aluminium and iron, and if you want to extract aluminium only in the presence of iron, then if you add alkali cyanide, okay, RCN, if you add alkali cyanide, then that formed with the iron ferrocyanide, which neither interfere in extraction of aluminium nor itself undergo extraction. That is a simple process. By addition of the alkyl cyanide, they process with that iron and form ferrocyanide ions. Okay, then in that complex iron is trapped, and because of that reason now aluminium is freely available for the extraction. Some masking agent are given here. First one, that is called citrate. Second one is the alkyl cyanide. Third one is called tartrate. Fourth one, that is the mechanism here, EDTA. Okay, when you add EDTA in the solution, aqueous solution having iron, what happen? It form complex like this. Now that Fe is trapped in that complex, Fe-EDTA complex. This complex is also not undergo extraction, as well as iron is also trapped in the complex. Aluminium can easily extracted by the solvent. That is the process or mechanism of the masking agent. All these agents work like that. Okay, here is a simple structure of EDTA, tartrate as well as the citrate. Next slide, I am going to discuss with you, that is the synergetic agent. Okay, don't confuse between the synergistic agent and synergetic agent. Synergistic agent means masking agent, EDTA, citrate, titrate, while synergetic agent, they are one type of additives. Additives mean they are added after the process is started. They are added to the organic phase. Yes, here one question for you. what is the difference between synergistic agent and synergetic agent? The difference is very simple. Synergistic agent are added in aqueous phase, water, while synergetic agent are added in an organic phase. That is the main difference between synergistic and synergetic agent. They increase the extraction, they form complexes which are taken out by the extractant in organic phase. Okay, here it is also important. Synergetic agent form the complexes and then that complex is extracted with the help of the extractants. For example, neutral organophosphorus compound mixed with acidic organophosphorus compound, which act as a synergetic agent. That is the example of synergetic agent. The next point, that is called modifiers. They are also one type of additives and they are added in extractant. Okay, here the word is important. They are added in extractant. Okay, modifiers are added in both. That means it is simply we can say that extractant means here. Extractant means the solvent which is extract the solute from another phase. That means it is either aqueous phase or organic phase. What is the difference between synergetic, synergistic and modifiers? Synergetic added in organic phase, synergistic added in aqueous phase, while modifiers add in both. Okay, it add in aqueous phase or in a organic phase. That means it depends on which act as a extractant. If aqueous phase is your extractant, then modifier add in aqueous phase. If organic solvent is your extractant, then it is added in a organic phase. That is called extractant. That means it is added in both the phases. Okay, they will increase the solubility of the metal ion in a solvent. Generally, high molecular weight alcohols are used as a modifier. That is the example of modifier. The next point, that is called oxidation state. You know what is the oxidation state. When electrons are removed from metal, okay, there was a positive charge, or if ion accept the electron, there was a negative charge. That is called the oxidation state. Depends on removal or addition of the electron. Now, how the oxidation state is affected on the process of solvent extraction? It is quite easy. It is possible to increase the selectivity by changing the oxidation state. That is important also for MCQ purpose. Okay, by or how you can increase the selectivity of extraction process. Options are given to you. The right option is by changing the oxidation state. Now, how it works? Okay, what is selectivity? Selectivity means when there is presence of more than one metal in the same solution, and if you want to extract only one in the presence of many, that is called selectivity. But now, how it can be achieved with the help of oxidation state? Let's see. For example, if in an aqueous phase which contain metal ion, okay, any metal ion, it is either a copper, zinc, nickel, doesn't matter, any metal ion that is present with FeCl3 solution. That means Fe plus 3 that come from FeCl3 solution. Keep in mind, Fe plus 3 comes from FeCl3 solution, and the metal ion, that means any other metal extracted in the solvent. Now both undergo extraction. If I want to prevent the extraction of Fe plus 3, then simply if I change the oxidation state of Fe plus 3 by reducing it to Fe plus 2, then Fe plus 2 does not undergo extraction. Okay, so that's how I change the oxidation state of Fe plus 3 into Fe plus 2. That means by reduction of that Fe plus 3 to Fe plus 2, and that Fe plus 2 ion does not undergo extraction. That means now the metal ion which is present with Fe plus 3 is undergo extraction. That means your process of extraction becomes selective by changing the oxidation state of Fe plus 3 into Fe plus 2. That's how the change of oxidation state works. Next point, that is called pH value. You know, pH is the scale, okay, the negative logarithm of the hydrogen ion concentration. That is called pH of the solution. the scale from 0 to 14. 7 is the neutral, 0 to 7 is the acidic, and 7 to 14 is the basic in nature. Here, how pH affect on a process of solvent extraction? That's easy. The process of liquid extraction is largely influenced by pH. Okay, how? Because two metals may be extracted at different pH value. That is the heart of the topic, that pH value. Okay, every metal extracted at different pH value. That means if you have a number of metal present in the aqueous phase or the organic phase, you just set the pH of the solution in such a way that at that pH only a single metal is extracted. Okay, I give you some examples so you can understand that things. Suppose the solution contains two metal ions. Now make the pH of the aqueous phase in such a way that only one metal is extracted. Now take out the extracted solution and again change the pH of the aqueous phase so that second one is also extracted. That is how the pH work. Okay, with the help of the diagram given here, that is the on y-axis the percentage of extraction, on x-axis the equilibrium pH. Now look at here. In your aqueous phase there are 1, 2, 3, 4, 5 copper, iron, nickel, cobalt and zinc. These 5 metals are present in an aqueous phase. If I want to extract only zinc, then if I set the pH of an aqueous phase to, look at here, that is 7.2. If I set the pH 7.2, then only zinc undergo extraction, rest of the 4 are not extracted. Similarly, if you want to extract the cobalt, then pH will be 4.8. For nickel it is 3. It is 4.2. Iron it is 2.2, and for copper it is approximately 1.0. By adjusting the pH of the solution in such a way that you can extract one by one all the metals from the aqueous phase. Okay, so that's all about today's lecture. You know my channel JJ's Classroom. If you like the video, then you can hit the like button and also subscribe my channel. Thank you for watching. Have a nice day.